Hey everybody, this is Larry. This is day 2 of the year of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's poem. Ooh, do, 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 do. Yeah. It's actually still January 1st for me. I did the polar bear dip today in Coney Island here in New York. But man, it is cold, I'll tell you that. And I'm a little bit tired as a result. But let's take a look at today's poem. 2610, convert an array into 2D array with conditions. That's a very mouthful-y sentence. But it's just by the number, it probably is from a recent contest, so I probably have done it recently. I mean, as you kind of saw. All right, let's see what is it about. You're given an integer array nums. You need to create a 2D array from nums satisfying the following condition. 2D array should contain elements of the array nums. Okay. Each row contains distinct numbers, and the number of rows should be minimal. Okay. I mean, it feels like I'm trying to figure out if there are any tricks to it, because it just feels like it is very greedy, right? Or like any minimal answer is good, and there's no constraint as to how many each they call it a row, but each row gets. So in that sense, I don't know. It just seems like then now the number of rows is just going to be the max of the element, and then in that sense it's greedy in that you just kind of put it in. But it also even doesn't even matter. You could just put them in anywhere you like, as long as you keep, yeah, as long as you keep them in a place that is not the yeah, as long as your answer is minimal, it almost doesn't matter, and it will be minimal if your max nums, the max frequency of your nums is your answer, right? So let's play around with it. So now let's just do a frequency table. This is how you do it in Python, at least very quickly, right? And then now, yeah, I mean, you have an answer. Maybe you would even do like for with key value in f dot item, something like this. Yeah, and then like just in v, which is the number of count you have, right? You just go. I guess you need I maybe, because then you can do something like f answers of I append k, and of course, maybe something like if length of answer is less than I. Is it I or I minus one? Something like this. Wait, is it? Huh. If I, then you could do it. Yeah. No. But then the opposite of this, right? Is what I want. Append an empty array. That's basically what I want to do. Sorry. And then that's pretty much it, right? Or am I misunderstanding this problem? It may be that I'm misunderstanding this problem, but alright. I mean, it works with examples. You could YOLO. Yeah. That's pretty much it. Basically, like I said, I mean, you could do it in a greedy way, of course, and you can prove that greedy is optimal. Greedy being maybe just put it in the first, but that's because a lot of things are optimal as long as you don't. Like, I almost feel like you have to go out of your way to make a wrong answer, because there's no really constraints, right? Or like the only constraint is the distinct integers, but beyond that, it's almost like, yeah, there are no other constraints. I'm trying to think. What's the way of saying it? But yeah. This code seemed pretty short. How did I do? What's that? 5-6 months ago. Wow. Why did I wait so crazy? Wow. What did I do before? And this is during the contest, so that's even kind of worse. Because the code that I wrote today was pretty tight. And you could even get a little bit tighter if you like, but I think for me, I like it's pretty reasonable. This one, what am I doing here? So for each number, oh, I see. Okay, I mean, I guess actually this is fine. I think this is fine. It's just going a per number at a time, and then you just find which of the answer to put it on. Where here we this kind of skips doing the loop, and then we okay, I don't know. Yeah, I mean this is going to be linear time because this is linear time, and linear space because this is linear space, right? I mean, for each item that appears in input, it appears here, so that's going to be linear space. This is this is linear time and linear space, so yeah, like for example, they're all unique. Yeah, that's what I have with this one. I mean, I don't know, it's a simple one. That's what I have. So stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.